So now we're going to look at two-sample hypothesis testing, but this time with dependent samples. What we did previously was independent samples. Okay, so in this case, remember with the dependent samples, we have a linkage between values in one population and the other. All right, there's a direct correlation link between these values. All right, so instead of just taking one of your samples and finding a mean there and taking the other sample and finding a mean there, what we're going to do is we're going to look at the difference between entries from each sample. So the ones that are connected, that are dependent. All right, so we're going to look at D. So we're going to calculate first, depending on how many pairs we have, that's how many calculations of D we're going to get, where we take one value from one sample and the corresponding value from the other sample. And then we get all these differences. And it's the differences that we're really going to be studying. So what we're going to do is get all those differences, and then for our test statistic, it's going to be the mean difference. So if we took all those differences, added them up, and divided by the number of pairs that we have, so the number of differences that we have. So this is the thing that we're going to be looking at. The test statistic being the mean difference from the samples, trying to understand what the population difference might be. So here's how it would look in the different cases, again, of having the different tailed tests. So the different cases here, in this first one, what we'd be looking at, again, is we're looking at, so mu D is that mean difference from the population. So the null hypothesis is that mean difference is 0, and the alternative is that mean difference is not 0. So a two-tailed case. And then with the one-tailed cases, we're either looking at the case where the null hypothesis says that the mean difference is 0 or negative, and another case where the mean difference is 0 or positive. And so we have our two-tailed case and our one-tailed cases. All right. Again, just like before, regardless of which hypotheses you use, you're assuming that mu D is 0 and seeing what you can conclude based on the samples. All right. So in order to do this two-sample dependent t-test, to test the mean of the difference for a population of paired data, we do need the samples to be randomly selected. We need the samples to be dependent, and we need the populations to be normally distributed, or the number of pairs of at least 30. So again, we need the same size samples from these two populations because they have to be paired. So we're talking about the number of pairs being at least 30. Okay, so what else here? Let's take a deeper look at the t-test for this difference between means. Again, like we said before, the test statistic is going to be this mean difference from the sample points, the sample differences. And the standardized test statistic, again, we're going to be using a t-test. So what is it? Well, it's going to be this test statistic that we calculated minus the mu D, the mean difference, over the standard error for these differences over the square root of n. So this is quite similar to everything we've been doing before. Again, because we don't know any population information about variances, we're using this sample standard error calculation, and that's given over here. So SD is equal to the square root of the sum of the squares differences over n minus 1, so this the number of pairs minus 1. And that's also very similar to what we did previously, and showing that the degrees of freedom is the number of pairs we have minus 1. So let's take a look at how the whole procedure would play out. So if you're going to do this paired or dependent sample t-test, we want to know the samples are random and dependent, and then we have to verify either the populations are normally distributed or the number of pairs is at least 30. As with any hypothesis test, we identify the null hypothesis and the alternative and see which one, where the claim is. Determine whether this is a left tail, right tail, or two tail. Specify the level of significance alpha. The degrees of freedom, again, that's just going to be n minus 1. Figure out the standardized test statistic, which can be done by the calculation or by technology, and have that lead us to the p-value. We finish it off in the same exact way as we've done with all our hypothesis tests. We use that p-value to make a decision to reject or fail to reject the null hypothesis. And then, based on where the claim was and whether we're in support or rejection mode, we interpret that previous decision in terms of the claim.